Welcome to Grade 10, Unit 4, Straight Lines. Lesson 3, Equation of a Line. This educational material was produced by Fanos, and I'm Jane, I'm your teacher for this course. The objectives for this lesson are to know the definition of gradient, to be able to calculate the gradient of a non-vertical line, and to be able to find the equation of a line, are to understand the meaning of parallel and perpendicular, and to be able to determine if two lines are parallel or perpendicular. We'll start with gradient. Have a look at these lines. Which line is the steepest? If we look at the angles, the blue angle, the green angle, and the orange angle, we can see that the measure of the orange angle is the largest. So the orange line is the steepest. Here are some more lines. Which line is the steepest in this case? Again, if we look at the measures of the angles, we can see that the green angle has the largest measure. So the green line is the steepest. What is the gradient or the slope? The gradient of a line segment is a measure of how steep the line is. Here's an example. To find out how steep this line is, we need to work out how much it's going up by. So if we take one step across and count how much it's going up by, we can see it's going up by 2. So the steepness of this line is 2. But sometimes we might want to go across by more than 1 when we're doing this measurement, like this. Here we've gone across by 2 and we've gone up by 4. So in this case, we need to divide this distance here by 2 because we've taken 2 steps. In general, the formula for the gradient is the change in y, so how much you've gone up by, divided by the change in x, how many steps across you've taken. So the change in y is how much you've gone up by, divided by the change in x. You can also write this using this notation here. This is a Greek letter delta. The gradient equals delta y over delta x. Delta means change, so this is just another way of saying change in y over change in x. In this example, the change in y is 4 and the change in x is 2, so the gradient is 4 over 2, which is 2. Here's an example where the line is sloping downwards. We can use our formula again, and this time we will notice that the y value is decreasing. It's gone from here down to here. The x value is increasing as normal. It's going across from left to right. So when we use the formula change in y over change in x, or delta y over delta x, we'll need to do -3 because the y value has gone down, divided by 5. So the gradient in this case is negative. When a line slopes downwards, its gradient is always negative. Example: find the slope or gradient of a line which passes through the points 4, 6 and 5, 3. Slope and gradient are exactly the same thing. They're just two words for the same idea. Let's start by labelling the points 4, 6 as x1, y1 and the point 5, 3 as x2, y2. Then we can use our formula for gradient. M is change in y over change in x, and we can write the change in y as y2 minus y1 because it's the difference between the two y coordinates. And we can write the change in x as the difference between the two x coordinates, x2 minus x1. So in this case, that's 3 minus 6 over 5 minus 4, which is -3 over 1. Which is -3. So this gradient is negative, and this line would be sloping downwards. Now let's have a look at some horizontal and vertical lines. Here's a horizontal line. It just goes straight across. In this case, the change in y is 0 because it's not going up or down, and the change in x is 5. So the gradient would be 0 divided by 5, which is 0. The slope of a horizontal line is always 0. Now let's have a look at a vertical line. The change in y is 4 because it's gone up by 4, and the change in x is 0 because it's not gone across at all. So the gradient is 4 divided by 0, which is not defined. The slope of a vertical line is undefined. What is the angle of inclination? It is the angle measured from the positive x-axis to a line in a counterclockwise direction. Here's a diagram to demonstrate. Here's a line segment from x1, y1 to x2, y2. And we can draw on the direction of the positive x-axis here. So the angle that we care about is this one here. It goes from the positive x-axis in a counterclockwise direction until it hits the line segment. We'll call this angle theta, another Greek letter. If we use our trigonometric functions, tan theta is opposite over adjacent. But in this case, the opposite line here is the change in y, and the adjacent line here is the change in x. So actually, tan theta is the change in y over the change in x. Or in other words, tan theta is the same as the slope of the line segment. Example, find the slope of a line if its angle of inclination is 45 degrees. To do this, we'll use the formula that the slope of a line is equal to tan theta, where theta is the angle of inclination. So the slope in this case is tan 45, which is root 2 over 2. Example, find the angle of inclination of the line passing through the points 4, -4 and -1, 1. We know that tan theta is equal to the slope of the line, so tan theta is the change in y over the change in x, which in this case is 1 take away -4 over -1 take away 4, which is 5 over -5, which is -1. So theta must be the inverse tan function of -1, which is 135 degrees. Point slope form of a line. Here's a line segment with gradient m. Here's the point x1, y1, which is a fixed point on the line. Here's a general point, which we'll call xy. This could be anywhere on the line. So it could be here, or it could be down here, or it could be up here. It varies along the line. We're allowing x and y to change, but x1, y1 is a fixed coordinate. In this case, if we use the gradient formula, we find that the gradient equals y minus y1 over x minus x1. And if we rearrange this, we can write y minus y1 equals m times x minus x1. This is the point slope form of the line. y1 is a fixed number, x1 is a fixed number, and m is the gradient, which is also a fixed number. Y and x are variables. Example, find the equation of a line with slope -3 and which passes through 1, 5. To do this, we can use the point slope form of the line, y minus y1 equals m times x minus x1. So y minus 5 equals -3 times x minus 1, because 1, 5 is the coordinate that it passes through, and -3 is the gradient. So y take away 5 equals -3x plus 3 by expanding. So y equals -3x plus 8. Slope-intercept form of a line. Here's a line with gradient m. Here's the point 0b on the line. This is a fixed point, and it's the point where the line cuts through the y-axis. Here's a general point on the line, which we'll call xy. If we use the point slope form of a line, y minus y1 equals m times x minus x1, then we can write in that y minus b equals m times x minus 0. So y minus b equals mx. So y equals mx plus b. This is the slope-intercept form of the line. M is the slope or gradient, and b is the y-intercept. The y-intercept is the name given to the point where the line intersects the y-axis. So this value of y here, which is b. Example, find the equation of a line with slope -3 and y-intercept 5. The slope-intercept form of the line is y equals mx plus b. The slope is -3, so m is -3, and the y-intercept is 5, so b is 5. And the equation is y equals -3x plus 5. Example. Find the y-intercept and the gradient of a line with equation 6x plus 2y plus 9 equals 0. To do this, we need to rearrange the equation. So if we take away 6x and take away 9 from both sides, then 2y equals -6x take away 9. If we divide both sides by 2, then y equals -3x take away 9 over 2. So the slope is -3 because this is the number that's multiplying the x, and the y-intercept is -9 over 2. Equation of a line using 2 points. You can use 2 points to create an equation for a line. Here are 2 points on a line. Let's call them A, x1, y1, and B, x2, y2. Here's a general point on the line, C, which is xy. So this point could be anywhere along the line. Then the gradient from A to B is y2 minus y1 over x2 minus x1. And the gradient from B to C is y minus y2 over x minus x2. This is the same line, so these two gradients must be equal. So this gives us the equation of a line using 2 points. Example, find the equation of a line which passes through 4, 0 and -2, 3, giving your answer in the form ax plus by plus c equals 0. Let's call 4, 0, x2, y2 and -2, 3, x1, y1. We could do this either way round. Then if we use the formula y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1, then we can say that y minus 3 over x take away -2 equals 0 take away 3 over 4 minus -2, which simplifies to y minus 3 over x plus 2 equals -3 over 4 plus 2. So y minus 3 over x plus 2 equals -1 over 2. If we multiply both sides by x plus 2 and both sides by 2, then we get 2y minus 6 equals -x take away 2. So x plus 2y take away 4 equals 0. And this is now in the form ax plus by plus c equals 0. A is 1, b is 2, and c is -4. To summarise, if P, x1, y1, and Q, x2, y2 are points on a line with x1 and x2 not being equal, or in other words, not a vertical line, then the angle of inclination, theta, is the angle between the positive x-axis and the line. And the gradient or the slope is equal to y2 minus y1 over x2 minus x1, which is equal to tan theta. The equation of the line with slope m passing through the point P x1, y1 is given by y2 minus y1 equals m times x2 minus x1. This is the point slope form of the line. The equation of the line with slope m and y-intercept b is given by y equals mx plus b. This is the slope-intercept form of the line. Review questions, part 1. Find the gradients of the lines passing through each pair of points. Pause the video whilst you work it out. Here are the answers. A, m is 3. B, m is -1. C, m is -1. D, m is 0.5. E, m is -1. Parallel lines are lines that never meet, or lines which are equal distance apart. What can we say about the slope of parallel lines? Here's a diagram. Here's one line with gradient m, and here's a parallel line with gradient n. The arrows here show that the two lines are parallel. If we draw on the two angles alpha and theta, then we know that alpha is equal to theta because they are corresponding angles. This means that tan alpha must be equal to tan theta. But tan alpha is the slope of this line, which is m, and tan theta is the slope of this line, which is n, so m must be equal to n. If two non-vertical lines are parallel to each other, then they have the same slope. Example, state if the lines in each pair are parallel or not. A. L1 is y equals 4x minus 6, and L2 is 3y minus 12x plus 9 equals 0. Let's rearrange L2 into the form y equals mx plus b. We'll start by adding 12x and subtracting 9 from both sides to get 3y equals 12x minus 9. Then divide both sides by 3 to get y equals 4x minus 3. They both have a gradient of 4, so yes, they are parallel. Example, state if the lines are parallel or not. Line A through 2, 5 and 0, 1, and line B through 4, 10 and 5, 12. The gradient of line A is 1 take away 5 over 0 take away 2, which is 2, and the gradient of line B is 12 take away 10 over 5 take away 4, which is also 2. So yes, the two lines are parallel. Example, find the equation of the line that is parallel to 3y minus 2x plus 6 equals 0 and passes through the point 1, 10. Let's start by rewriting the line in the form y equals mx plus b. 3y minus 2x plus 6 equals 0, so y equals 2/3 x minus 2. So the gradient of this line is 2/3. This means that the gradient of the line that we're trying to find is also 2/3. So we want to find a line of the form y minus y1 equals m times x minus x1, where m is also going to be 2/3, and x1, y1 is going to be this point 1, 10. So y minus 10 equals 2/3 times x minus 1. So y minus 10 equals 2/3 x minus 2/3. So y equals 2/3 x plus 28 over 3. Perpendicular lines. Here are two perpendicular lines. Perpendicular lines always meet at right angles. If we create two triangles from these perpendicular lines and label the angles in the middle as beta and theta, then in this triangle we have beta plus 90 degrees plus something makes 180, but we know that beta plus 90 degrees plus theta makes 180. So this angle must be theta, and the same on the other side, this angle must be beta. So we have two similar triangles. Triangle CDO is similar to triangle OAB. This means that the ratios of their sides are equal. So the ratio CD over DO is equal to the ratio AO over AB. If we divide both sides by AO over AB, then CD over DO times AB over AO equals 1. And now if we label the coordinates, so that O is x0, y0, C is x1, y1, and B is x2, y2, then we can write CD as y1 minus y0, DO as x0 minus x1, AB as y2 minus y1, and AO as x2 minus x1. If we rearrange the denominator of this fraction so that it's of the form x1 minus x0, then we can put the negative symbol at the front, and we have that negative y1 minus y0 over x1 minus x0 multiplied by y2 minus y0 over x2 minus x0 equals 1. Or in other words, m1, the gradient of the first line, multiplied by m2, the gradient of the second line, is equal to negative 1. This is always true for perpendicular lines. Example, state if the lines in each pair are perpendicular. A. L1, y equals 2x minus 6, and L2, 3y minus 6x plus 12 equals 0. Let's rearrange the second equation to become 3y equals 6x minus 12, so y equals 2x minus 4. Then if we have a look at the gradient of the first one is 2, and the gradient of the second one is also 2. And if we check, 2 times 2 does not equal negative 1. So no, they are not perpendicular. B. L1, 18y minus x minus 36 equals 0, and L2, 2/3 y plus 11x plus 9 equals negative x. Rearrange the first equation to get 18y equals x plus 36, so y equals 1/18 x plus 2. And rearrange the second equation to get 2/3 y equals negative 12x take away 9, so y equals negative 18x take away 27/2. And now if we have a look at the gradients, 1/18 multiplied by negative 18 is negative 1. So yes, these two lines are perpendicular. Example, a line AB joins the points A, 3, 4 and B, 5, 8. A line perpendicular to AB passes through the origin and the point 6R. Find the value of R. To do this, we'll start by finding the gradient of the line joining A and B. It's 8 minus 4 over 5 minus 3, which is 4 over 2, which is 2. So the slope of the perpendicular line must be negative 1/2. The slope of the perpendicular line can also be found by doing r minus 0 over 6 minus 0, because we know that it passes through the point 6r and also through the origin 0, 0. So we know that negative 1/2 must be equal to r minus 0 over 6 minus 0. So negative 1/2 must be equal to r over 6. So r must be negative 3. Example, find the equation of the straight line that is perpendicular to y equals 1/2 x plus 1 and passes through the point 1, 3. We can use the form y minus y1 equals m times x minus x1. We know that it passes through the point 1, 3, so we can put y1 equals 3 and x1 equals 1, and we also know that the slope is going to be the negative reciprocal of 1/2, so it's going to be negative 2. So y minus 3 equals negative 2x plus 2, so y equals negative 2x plus 5. Example, A is the point 1, 3 and B is the point 3, 5. Find the equation of the perpendicular bisector of AB. The gradient of the line joining A and B is 5 minus 3 over 3 minus 1, which is 1. So if we use the form y minus y1 equals m times x minus x1, then we know that m is going to be negative 1. We also need to find the midpoint of AB, because the perpendicular bisector is going to pass through the midpoint of the line joining A and B. To find the midpoint, we do x1 plus x2 over 2, y1 plus y2 over 2, which is 1 plus 3 over 2, 3 plus 5 over 2, which is 2, 4. So the equation becomes y minus 4 equals negative 1 times x minus 2. So y minus 4 equals negative x plus 2. So y equals negative x plus 6. To summarize, if two non-vertical lines are parallel to each other, then they have the same slope. If the product of the gradients of two lines is negative 1, then the two lines are perpendicular to each other. If two non-vertical lines are perpendicular to each other, the gradient of one is the negative reciprocal of the other. Review questions part 1. Suppose a rhombus ABCD is drawn on a coordinate plane with A equals 4, 7. The diagonal BD lies on the line y equals 2x minus 5. Find the equation of the line that passes through A and C. 2. The equation of line L1 is y equals 2 minus 5x. The equation of line L2 is 3y plus 15x plus 17 equals 0. Show that these two lines are parallel. Pause the video whilst you work them out. Here are the answers. For number 1, the line through A and C is perpendicular to y equals 2x minus 5, so the gradient is negative a half. Then y minus 7 equals negative a half times x minus 4, which simplifies to y equals negative a half x plus 9. For number 2, let's rewrite the equation 3y plus 15x plus 17 equals 0 as 3y equals negative 15x take away 17, which then simplifies to y equals negative 5x take away 17 over 3. So both lines have a gradient of negative 5, so they are parallel.